A couple of binomial expansion questions here. Now, here is the formula. So for us, A is going to be 2, B is going to be minus x, and N is going to be 8. Then 2 minus x to the 8 is going to be, just replace your A's and your N's and your B's in the formula. So 2 to the 8 plus 8, choose 1, 2 to the 7 times minus x. And every time I'm basically lowering the power of the 2 and increasing the power of the minus x. Then we get 8, choose 2, 2 to the 6 minus x squared, plus 8, choose 3, 2 to the 5 minus x cubed. That is the first 4 terms. And then we can use our calculator to work some of these out. So 2 to the 8, 256. 8, choose 1. There. Actually, this is just 8. Oh, and then I have to times by 2 to the 7. 1024. But actually it's then times minus x. So I'm going to get minus 1024x. The next one is 8, choose 2, multiplied by 2 to the 6, 1792. And then it becomes x squared when I square it with the minus x. Finally, 8, choose 3 times 2 to the 5. Again, 1792, but this time it's minus. And that is going to be our answer. In part B, we've got a different binomial expansion, but we're just asked for the term independent of x, so it's going to be a constant term. Now this time, when I find my first term, I would actually get root x to the power of 10, which would become x to the 5. This is dependent on x. The next one would then be 10 choose 1, root x to the 9. And then I'd be timesing by minus k over x squared. This would still be a higher power than, but it wouldn't be just, I'd get x to the 4.5 divided by x squared. I'd actually get x to the 2.5, but you can see that it's going down. I'm just trying to explain that at some point they're going to cancel each other out perfectly. So maybe there's two wet methods to do this then. We could just keep going down until it kind of works. Now it's going to have to be an even power for it to work. So if I went with root x to the 8, and I'll forget the k, 1 over x squared squared, then actually that's gonna work, because here I'd get x to the half to the 8, that would be x to the 4, and here I'd times by 1 over x to the 4. So it's going to be that term there that I'm interested in. And therefore, my coefficient is going to be 10 choose 2, because I'm actually using this bit here. So it's my second term to the power of r. It's my minus k over x squared squared. That's where the 2 comes from. That's why I put a 2 here. Could also do 10 choose 8. It's the same thing. But then I'll be timesing by root x to the 8 times minus k over x squared squared. That is my term that's going to be independent of x. That is going to equal 405. Before I solve this, I'm just going to show you one other way that you could get it. It's a slightly more sophisticated way than just trying numbers out, but trying numbers out does work. Okay, the more sophisticated way is to say, right, I've got root x and I've got 1 over x squared. Forget the k, that's just a constant in there. I'm going to raise this to some power. Let's call it p. And then this one is going to be raised to 10 minus p. Because if this was 2, this would be 8. They always add up to 10 between them. It would then become x to the half p multiplied by This is x to the minus 2, so I'd actually get 2p minus 20 when I sort that out. And I want this to equal 1. So that means I can add the powers. I know it's more complicated for sure, but you know, it is like a algorithmic way or a process to follow to do it rather than just trying things out. So then a half plus 2 is 5 over 2. So I get 5 over 2p minus 20 equals 1. And it must be that this power is 0 to get a constant. So 5 over 2p equals 20. P is going to be, well, 5p is 40. P is then going to equal 8. So you can see I get the method without just trying it out. Okay, let's finish this off. So 10 choose 2. It's 45. So 45 x to the 4 times k squared over, remember the negative just disappears when I'm squaring it, over x to the 4 is equal to 405. So the x, these cancel, there we go. Got my term that's independent. The coefficient of this independent term, or just a constant term by itself, is going to be 45k squared. We're told that it's 405, so I'll do 405 divided by 45, which gives me 9. K squared is going to equal 9, and therefore the possible values of k, take plus or minus the square root, it's going to be plus or minus 3.